Example 2 says let r of x equal that polynomial there, or that rational function. Determine the real number values of x that cause r of x to be 0, undefined, positive, and negative. So, how am I going to find where it's going to be 0 at? What's another word for 0? Solution, x-intercept, right? We talked about rational functions, how to find the x-intercepts. How do we find them? The numerator is equal to 0. So, I'm going to use this little room above that box there. Remember, your numerator is equal to 0. So, in this case, x plus 3 times x minus 5 will equal 0. Set them individually equal to 0 and solve. Alright, so my zeros are going to be at x equals negative 3 and at x equals 5. Excuse me. B wants to know where is it going to be undefined at. What does it mean undefined? What would make my function undefined? If we had 0 on the bottom of a fraction, right? So where is it that the denominator is equal to 0? What did we call that? Started with a V. E. What? Yeah, it's the vertical asymptote. So, I didn't write it here, but I guess I could have. When we did the x-intercept, when we did the 0, we found the x-intercept. So I'm going to go ahead and write that. And so when we're looking for where it's undefined, we're looking for that vertical asymptote. Bless you. Alright, so to find it, remember, that's where your denominator is equal to 0. So in this case, it's where 2x minus 1 equals 0. Solve for x. So add the 1 and divide by the 2. Alright, so how am I going to find where it's positive or negative at? How did we do that in example 1? Yeah, we used that number line, didn't we? Alright, so remember on your number line, you're going to have your infinities. And what did I say you were going to put on that number line? Your x-intercepts and vertical asymptotes, which is what we found in A and B. So we're going to put all 3 of those numbers on there. In order. And then we're going to pick some x values in between them. So what's a number in between negative infinity and negative 3? What about between negative 3 and 1/2? And between 1/2 and 5? And between 5 and infinity. Yeah, guys, and it's always easier because we're plugging them in solving if you pick the ones close to the actual number, okay? So like negative 3, negative 4 was great. Between negative 3 and 1/2, I definitely would use 0 if it's available, okay? Now 0 is an x-intercept, or if it's a vertical asymptote, obviously we can't use it, but 0 is easy to plug in and solve with. So, always try to find smaller. Like between 5 and infinity, I could have picked 1,000, but I'm going to have to plug 1,000 into my equation and solve it, and I don't want to do that. So, it's always easier to pick numbers closer to your critical values there. Alright, so let's plug in 4. Negative 4, excuse me. And check my work because I make mistakes. I didn't do it last time, but this time I'm going to go ahead and put the y equals. So it's y equals -1. And then I'm plugging 0. Is anybody actually working these out? Did you get the same thing for 6? Okay, I was a little iffy on that one. Just want to make sure. Okay, now in example 2, it does want me to graph it. So I could graph just a quick little sketch. My x-intercepts. An x-intercept where we say -3, and at 5 we had vertical asymptote at 1/2, I'm not going to scale my y-axis, so that way I can't be too far off, right? And we can go through, if nothing else, I mean, we have these points. We know that between -infinity and -3, what kind of y values are we going to have? They're going to be negative. So they're going to go up or down. So don't draw this on yours. I'm going to look at this. So from here to here, it has to be going down. Okay? From -infinity to -3, where I just drew that little squiggle thing, it's going to go down. Well, it's going to come out of the -3, and so we're just going to make it go down. Okay, so now we also know, though, between -3 and 1/2, what kind of y values did we have? Positive, because that 15 is positive, okay? So, oops, let me change back to my gray so my color is all the same. So we know that the 15 was positive. So if it's positive, am I going to go up or down? Up. That's where my positive numbers are. And so you always come out of your x-intercept, and so we're just going to go up. And then between 1/2 and 5, between the 1/2 and 5, what kind of y values did we have? Negative. So is it going to go up or down? Now remember, we're always going to come out of the y-intercept, okay? So I'm going to have to come out of that y-intercept and go down. And then between that that +5 and infinity, I look over in my sign table here. And what kind of y values did we have? Positive. So we're going to go up. Now, what we didn't graph here, what we didn't find was look at it. We have somewhere in there we got that slant asymptote going on, okay? We didn't have to graph it, but I just wanted you to know that's why my things are curved the way they are. And I could tell that because when I looked at my equation, where's that equation at? The largest exponent on top is x squared, and the one on bottom is x. So therefore, the top is bigger than the bottom by 1, which means there is a slant asymptote there. So that's why they're curved, kind of weird looking there. All right, but that gives us a rough sketch of our graph.